Welcome to video 7. So we spent some time covering this Base62 encoder and porting it to different programming languages and using that as a way to kind of see what modern programming languages supply and how well they support functional programming. So this week we convert the Base62 example to Python, and I'm going to say that, to me, I have a Scala background. I really enjoy programming in Scala. Python is very comparable, and there's a lot of nice features in Python, and it's much better than I would have imagined, and it kind of makes sense based on my experience with Apache Spark. So that's what we're covering this week. It's pretty exciting. Next week the next show we're going to do TypeScript and JavaScript, and then we have Rust, Kotlin, and Go, and I believe that is all. So welcome aboard. Let's get the year started. Let's go! Woo woo! Is video 7, which is the show notes for the Python Base62 encoder. So if you have been following, and first video we did was on implementing a ring buffer, got 233 views, also wrote a couple of articles on it. Then we improve the ring buffer, we make it 200% faster. And then there's a little project I did just to learn a couple different languages. I was kind of interested in kind of comparing the functional aspects of different programming languages. So I wrote this little Base62 encoder, which you typically see for URL shortening, so like bit.ly and whatnot. So I describe what that is, and then I'd show an example in Java, and that was video 3, and then video 4 I convert that into video 5, I convert that into Scala, functional Scala. First I do a direct translation into Scala, and then I convert it back into Java functional. So it went from Java to Scala functional to Java functional. And we cover that here, compute value, and that's the non-functional Java version. And this is the first version in Scala. No, that's the first. Yeah. And then we have the first version in Scala, and then the second version in Scala. So that's video 5. Video 6, we converted that to Clojure just to see what that would look like. So we took the functional Scala version and we converted that into Clojure. So now in this series, I also wrote this in Rust and TypeScript and JavaScript and Kotlin and a few other languages. So this particular show, to kind of kick off the season, took a little bit of a break over the holiday season. This particular show, we're going to be talking about Python. So again, here's all the background information about URL shorteners, a couple of examples. We have some explanation here of how the URL shorteners work for Wikipedia and for what Base62 encoding is. And here's some architecture descriptions, but we're just covering the actual encoder. So here is the Scala version, and to the right is the Python version. Okay, so I did some screen readjustment, and this is our main method here in Scala. We're calling convert to encoded string, convert to long, and then we use this URL and we convert that, and we use the println to print out the result. So we call convert to encoded string, convert to long, and then we do the equivalent in the Python world. So we call convert to encoded string, convert to long. Notice I follow the snake case because, I want to be what's proper for the language. And then we get the hash code for the URL ID. You can see the code is equivalent. Here's the URL ID. We get the hash code, and so on and so forth. So very equivalent code. Now let's go down and look at the actual convert to encoded string. So the convert to encoded string, it's actually pretty nice, the Python version, in that it's pretty much a direct translation. So you have a builder. It's just, Python's a dynamically typed language. One might say untyped, although they did add typing support more recently. Here you have the placeholder to look for the first start bucket. You can see the code is pretty close. Here we're grabbing the result from the accumulate digits, which is the second item in the tuple. So slight differences, but here's the power digit base using the snake case, obviously, and here's the one in Scala. The code is very, very similar. Here's the accumulate digits for an example. Of course, this is all typed, and this is all untyped, but you can see the logic is the same. Placeholder less than 1, less than equal to 1. Return it. And then otherwise, we call pile digits base, and we get the index, and then we call accumulate digits, and here we call accumulate digits. So the logic, placeholder -1, placeholder -1, accumulator minus bucket size times digit index, you can see the logic is the same. Much more so than even the using Java versus Scala. Much more the case that Python, because it is a functional programming language as well, that things fit really well. And if you've ever worked with, for example, Apache Spark, and you've done things in Python and Scala, you can definitely see some of the similarities where the Python code looks a lot like the Scala code and vice versa, to a degree. Here we have range in Scala, and here's the equivalent in Python. And Python uses this for loop syntax. And here we do find, and we're using a function that we pass to the find method. And here we use this for if. Now, if you've read some of the papers by Guido van Rossum, when he talks about functional programming in Python, there are certain things, for example, like the find method, the map method, etc., which he isn't a big fan of. So what you have instead is this loop comprehension. So it does the same thing, but one might argue more naturally or not, depending. Okay. So that's the Scala versus Python. Then we have the pile digits base. This code is nearly identical. Of course, it's Python, so we need a return statement, and we don't have the boxes, the brackets, but otherwise, and we also don't need the types. But you can see that the logic is almost identical in these two. Now, append saved to list. In Scala, I decided to use a list. In Python, I used some sort of string builder. So it's a little bit different logic, but you can see it's very similar. It's actually closer to the Java version. For the convert to long, this is one of those things, if you read the Guido van Rossum's ideas on things like reduce and map and whatnot, there are libraries that provide that functionality to Java. This is the Func Tools library where you can get a lot of that, but it's not at part of Java. So here, reverse fold left, that's part of Scala. Here, this do reduce, I use an inner method. So do reduce is the inner method to convert to long. It's just easier, I found, than trying to write the lambda expression in Python, or the equivalent of the lambda expression in Python. It could have been done that way as well. But this code would be like the body of the fold left here. So we get the accumulator in the position, we calculate the value, calling compute value, and then we return a tuple. And here we return a tuple. So very similar. And then we call fold, passing do reduce, what we're going to start things with, just like here, what we're going to start things with, and the characters. And then we return the result. Here you don't have to call return result because it's implicit, because it's Scala. So Python, I think, is very close, but because they don't actually encourage those, or, I mean, their libraries exist, but the creator of the language isn't a big fan of things like reduce and map. So it appears, although I think a lot of people that use Python are. So here's compute value. And you can see the logic is very, very similar. We find the index, get the multiplier, and we return the digit index times the multiplier. Here we don't have the call return, here we don't need the brackets, but pretty close. So this is the full Python example. This is going to be a small video. Compare it to the Scala version. You can look at the previous show notes to see the code for the various versions, and you could compare them as well. And that's kind of the gist of it. All right, let's pull down the code and try it out. So I'm going to go to GitHub repo, call maker base 62, change directory base 62, git clone. All right. Let's open up IntelliJ. So we pulled the code down. Let's make sure it's there. Tree, cat. All right, there's our code. Yeah, this is a machine that I haven't used with this before, so I don't have the plugins, I suppose. Okay. Pull up IntelliJ. Gonna load this in IntelliJ here. There we go. Base62. Don't think I'm going to create a virtual environment for this, since it's not going to include a lot of other packages. Okay, we can see their README. And then over here, we find the source. Take a look at this. So I convert to encoded string. Find start bucket, pal digits base, do pal, accumulate digits, append safe, so on and so forth. So then we should be able to run this. We can see our output. Then we can see our URL ID is the same, so we convert it to a string, and then we convert it back to a hash, and we get the same number out. So this one matches identically what we have in the Scala program, that DTVD30. It ends up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That works exactly the same in the Scala and the Java and now the Python. And in here, we take the hash of the URL, we convert it to a short handle, and then we convert it back to a hash. So that's what the main method does. So convert it, and then we convert it back to show that it all worked. So that's the gist. So that's Python. So next week we're going to cover TypeScript and JavaScript, and then we will cover Rust, Go, and Kotlin shortly after that, and we'll wrap up this and we'll start going into some of the computer science algorithms, data structures. Hopefully you enjoyed this. Provide some feedback. Thanks.